This video is support for the hole identification exercise in your workbook. This is a fairly easy exercise, but as you go through it, you can get a little bit confused about what's going on if you haven't been working with the orientations. And when I say orientations, you're given an isometric view like this, and when you're given an isometric view, you are to assume that the front view of the object is this plane, which corresponds to the front view on my navigation cube that I have here in Inventor. The right side would be that view, and the top would be this one. The top is actually a little bit different because it would be like if you were standing here and kind of leaning over and looking down at the top view. Okay, so you have to be aware of that as you go through this exercise. As you can see from the, you get a layout arrangement like this, but as you can see, these holes, they don't just go to the middle and stop, they go all the way through. So on this top plane, this 0.380 diameter hole goes from the top down to the bottom. The 0.370 diameter hole on the right side goes all the way through, all the way to the left side, and the 0.375 diameter hole in the front goes all the way to the back. Okay, so when you're looking at your orientation here, realize that this is your front view. Okay, this is your top view, this is your bottom, this is your right side, this is your left side, and this is your back view. Okay, so when you're going through your exercises, I'll show you the actual 3D representation here. I'm going to go to the front view. Okay, I'm looking at the front view perpendicularly now. Let me turn my hidden edges on so it'll look more like the book. Okay, so if I want to see the left side, I just want to rotate the object 90 degrees to the left, and if I want to see the back of the object, I rotate the left view 90 degrees further to the left, and I can see the back. That's probably the most confusing, okay, because if you think about it, you could actually start off in the front view and rotate the object toward you and then toward you again and see the back view. But as you can see, looking at the nav cube, the back of the object is actually upside down at that point. Doesn't matter as much with this object, but some objects it does matter how you rotate it. Okay, and when I say it doesn't matter as much with this one, it's because we're only looking at the diameter of the hole and it's centered up on the object. But if the object were off center, then it would change your back view. Okay, so be aware of that. Also, for example, if you're given a dimension in the center of the hole, like letters A, B, C, D, whatever it is in the center of the hole, it's actually talking about the circular view of the hole. It wants to know the diameter of that circle. Okay, at that point. And if one of the dimensions are pointing at an edge, then it is, for example, say that a dimension was pointing at the left side of the front view here, and it was pointing to the middle center line of this horizontal hole, then it would actually want to know the diameter of the hole that passes from the right side of the object to the left. Okay, that's what it's wanting to know. So again, if you have one of the dimensions and it's pointing at the edge here, okay, they're usually pointing at, they're all actually, the ones that are pointing at the edge are also pointing at the center line of the hole that passes through. So if you had one pointing, let me just point directly at it. If you had one pointing right there, okay, then it's actually wanting to know the diameter of the hole that passes from right to left on the object. So in that particular case, it would want to know the diameter of this hole. Okay, this hole right here. So just be aware of that as you go through the exercise, and hopefully that'll help you through. And just this is a little more help with your orientations. And that concludes this video.